lecture, we will talk about random number generation in Python and NumPy. First, talk about random number generation with Python random module. Python defines a set of functions that are used to generate or manipulate random numbers through the random module. Functions in the random module rely on a pseudo-random number generator function random, which generates a random float number between 0 and 1. So first we import a random, then use random.random to generate a random number between 0 and 1. And we can use choice function in the random to generate a random item. The choice function is an inbuilt function in the Python random module that returns a random item from a list, tuple, or string. So first import random, then we can print a random value from the list. So list 1 is a list with 6 elements. And next we can use random.choice parentheses list 1. Then can print out. Then this is one of the elements in the list 1, but it's random. And we can also print a random item from the string. For example, string is driver 7 alphabets. Then we can use random.choice string to select randomly one alphabet from this string. And generating random numbers from a special range and a step, we can use random range function. So using random range to generate in range from 20 to 50, for example. So the last parameter 3 is a step size to skip 3 numbers when selecting. So we can use random.range 20, 50, 3. Then it will be print out a random number between 20 to 50 and with a step of 3 after 20. But it's random. And we can use seed function to save the state of a random function so that it can generate the same random numbers on multiple executions. So for example, if we set random.seed7 here, then we can generate a random number and print out. And next time we can set a seed5 and then generate random number again. Of course, these two will may not be the same. But again, we can set a random seed again with 7, then print out this random number. Then this will be the same as this one. And we can use shuffle function to generate random number list in Python. So if you want to change the position of the elements of a sequence, so for example, sample list ABCDE is a list with 5 string values. Then we can use random shuffle sample list. Then next we print out the sample list. It will have the same elements of the original sample list, but the order of the elements has been changed. We can use uniform function to generate a random number list. So this function is used to generate a floating random number between the numbers mentioned in its arguments. So it takes 2 arguments, lower limit included in generation and upper limit not included in generation. For example, we can print a random number between 5 and 10 using the function random.uniform510. And next we talk about random number generation with NumPy's random module. So the NumPy's random module supplements the built-in Python random with functions for efficiently generating whole arrays of sample values from many kinds of probability distributions. So for example, we can generate a 4x4 two-dimensional array of samples from the standard normal distribution using normal function. So np.random.normal, we put the size here. If we do not set other arguments, so it will be a standard normal with mean 0, standard deviation 1. But we can also set the standard deviation mean and standard deviation 2 and mean value 5 in random normal. So this will print out a 4x4 two-dimensional array with each value has normal distribution with mean 5 and standard deviation 2. And you can also use random n to generate standard normal deviation values. So np.random rand_n. And similarly, we can also set a seed in NumPy. So you can set np.random seed 1, 2, 3, 4, for example. Then we can generate standard normal deviation array, two-dimensional arrays. And next time if we set random seed 1, 2, 3, 4, then create this random number array will be the same. And to shuffle an NumPy array, we can use np.random shuffle AIR. So AI is an array 1, 2, 3, 4, 5, 6. Then this will change the sequence of this array. And next we talk about can use NumPy random permutation method to get the random sample of sequence of permutation. So for example, we can use np.random permutation 20, then create a sequence of 20 with elements 1 to 20, but the sequence is random, not necessarily the first element will be the 1, maybe the first will be 10, but all the elements in this array will have the elements from 1 to 20. And for the two-dimensional case, if we create a two-dimensional array with 12 elements and 4 row by 3, then we use random.permutation, then along the first axis, here is the row, so 4 rows will be randomly arranged in the result. We will show this later in code. And this list is a partial list of NumPy.random functions. So here we can see many different statistic distributions you can use. For example, binomial, beta, chi-square, gamma, uniform, and this is random integers. This is for standard normal distribution, and this is for the normal distribution. We can set mean and standard deviation. So we will show all these statements in Anaconda Spider now. So first we see the file called section 10, the NumPy library.py, and the links to this file will be put in the description of this video. So first we move to lecture 8, random number generation in Python and NumPy. So generating random number in Python using random function. So first we generate a random float number between 0 and 1. So in Python we import a random, then create a number using random.random. Then we print out this number. So this is between 0 and 1, a random number. Then we use generating a random item using choice. Import. So first we create a list. List 1 is 1, 2, 6. Then we use choice to select one item. So this time select one item is 1. Next we can run again, for example, is 4. Every time may not be the same. We can also use this for the string, create a string first. Then next time we use a random choice to select the element from this string. I, this time is I. We'll run again. S. To generate random numbers from a specified range and a step using random range. So in the random range is generated in range from 20 to 50, and the gap is 3. So we can use this random range 20, 50, 3, 29. So 29 is over 20 with 3 plus 3 plus 3 is 29. Okay, run again. 23. So 20 plus 3 is 23. And we can use set seed to generate same random number in the different runs. For example, we set random seed 7 first. Then we can create a random number. So it's 0.32. Next time we can use random seed 5 and create a number. 0.62. Then we set seed to 7 again and create a random number. It will be the same 0.32 as the first round. We can generate a random number list in Python using shuffle. So create a sample list A, B, C, D, E. Original list A, B, C, D, E. Then we use a random shuffle sample list and print again. We have to see after the first shuffle the sequence has been changed. Then we can run second round, for example. Now the sequence is like this. And generating random number list in Python using uniform. So we create a uniform distribution number between 5 and 10. This is this number randomly selected from between 5 and 10. So now we see the case in the NumPy's random module. So generate a 4x4 array of samples from a standard normal distribution using normal function. So import NumPy as np first. Then we can use random NumPy np.random.normal. We put the size here and we do not set the mean and standard deviation. Then it will be default value with mean 0 and standard deviation 1. So we'll create 4x4 array. So this is standard deviation matrix with 2-dimensional array, 16 elements. Next, we can create a normal distribution with mean 5, standard deviation 2 with the same shape. So this is normal distributed with mean 5, standard deviation 2. And we can also set random seed 1, 2, 3, 4. Then create a standard normal distribution array. So we see this, then we can run again. It should have the same value. Run again, same value. Because we use the same seed. And the standard normal distribution can also use random n. 10 value standard normal distribution. We can shuffle and NumPy array. This is the original array. Original array print out 1, 2, 3, 5, 4, 5, 6. Then we shuffle, use np.random shuffle. Then we print out next we can use a permutation method. So this is a permutation of 20 elements. You can see a random sequence of 20 number from 1 to 20. And for the two-dimensional case, first we create an array with the shape 4, 3. Four rows, 3 columns. The next we can do the random dot permutation of this array. Then we print out to see how it's going. Now the row has been randomly selected, sequence changed. So now this is the first row, second row, third row, and fourth row.